Alright, I'm going to show you guys how to make a micro flash column, and what we're going to use is these little micro barrettes. The problem is they're long enough to put the silica in, but they're not long enough to put the solvent reservoir. You need a little bit more fluid in there than these hold. So we're going to try and extend it. So Hannah's going to help me do this. She's going to hold those things together and pick them up. And the first thing we're worried about is maybe contaminating stuff, so we're going to just wrap Teflon around it. And this is a work in progress. I did the no-no. I got the Teflon all nice and into one band, but I want it to be kind of flat. And hold on. And then see if we can turn around a little bit so you guys can kind of see what we're doing. Then I'm going to give that a tight pull, and then the way we're going to seal it is with just some parafilm. And for me, parafilm is awful if you're trying to get the edge off, so I break it, and once you break it, you can kind of start to see how to get access to that parafilm. But if you have sharp fingernails and sharp eyes, you think you might tear the paper apart without breaking it. Good luck on that. I've never had any success. And then this, in theory, is going to just keep the Teflon in place and also create enough seal, but we're concerned a little bit about how parafilm might interact with the ethyl acetate. So Teflon is a pretty universal, doesn't bind to anything. Sadly, that's why it's a forever chemical. And then put that on nice and tight. So now on there, and then kind of, I'll try and zoom in on this in a minute. There you go. So we've got Teflon in the center, and then parafilm surrounding. Alright, now we're going to... Alright, so now we've got our monkey bar set up in place. We got some little finger clamps in here. What the idea is that we need one for the lower and the top, and the height we're looking for, so get those aligned above each other. And when I build these monkey bars for this deal, here I'll do that. I extend that as far out as I can. So I got as much length on that 3-finger clamp as I can get. So that's one thing I might point out. Once they're pretty square on each other. Okay, now I'll trade in a place. You can hold that in place and I'll clamp it up. Now the height she's looking for is the height so that when we start running sample, we can drop test tubes in there, and it's not a guess on where you're going to hit. So she's going to bring it down close to the lip. That's about right. And that's where I'm going to lock that one on place. And then lock the top. I want to make sure that's good to where I push it. It's not going anywhere. And then the other thing about that is that if I get these 150 tall boys, they also fit, and that's going to be my waste container. So I'm going to get everything all marked up. I got my waste container, capture, mark that up. I've got my tubes, they're marked 1, 2, 3, or however many you're going to need for your experiment today. And now I'm going to show you how to pack the column. Now the other thing you need is you need a tube. And then if you look, there's a fitting, the same size of fitting that hook this. And I don't know if you see how this is all hooked together. I want to show you that real quick. So what goes in the bottom of these glass tubes, they look like this. They're little parts. And they fit perfectly inside of here. And if you look, the one on the bottom should have one of these frits. That'll prevent anything from falling through. Classically, in chromatography, that would be a glass wool that you put in there. And then you got your Teflon, or your your stopcock. Just a reminder, when it's parallel with the glass, it's on. When it's perpendicular, it's off. That's true of most ball valves. So I'm now in the off position. Then when you want to put the valve on it, they just fit. They just grip by a little bit of friction. So it's a friction grip. So it doesn't really fit, like it's not totally, it's not fastened in there with any screw threads. Okay, so there's that. Then I put another one of these on a tube, and this is going to be later. What I'm going to do with this is I'm going to use this for what we call flash chromatography if I want to speed things up. So that's what that's all about. So we're going to load the column first. Okay, what we're going to try and do is slurry pack this column. We'll see how it works. First thing you do, we got a little filter, and then a funnel to put stuff into your columns. That can fit in there for now. We got our column off, we got our waste underneath. I'm going to just get a little bit of solvent in there. It's good to build on top of this. Okay, so we're going to, and the idea is when you dissolve this stuff, it actually gets kind of hot, and sometimes if you dry pack it where the solid's already in there and you put fluid on it, when it starts getting hot, it just starts to blow itself apart. You want it to be tight. So what we do, this is called slurry packing. You can put a little bit of your solvent. We're using the ethyl acetate. And we're just making a slurry. And then when we dissolve it in here, or push it in there, it's not dissolved, it's just suspended. And we're going to try and push it onto the column. Oh, there we go. Wrap this good while it's going. There it goes. And the only thing here is you can see a fluid level on top and there's solid underneath, and you just don't want that fluid to drop past the solid. You always want, once you get your column built, you always want a little bit of fluid above the column. And one of the things I do too when this is happening, it's good to just kind of wrap on it, and it makes it settle up nice and smooth, and there's no pockets or holes in there. I do have a little bit of silica kind of on the top of the top wall. I want to wash that on down. I don't want that in there. I want it down inside the column. Again, the fluid levels up here. The solid starts here, and I just don't want the fluid to pass the solid. So if I'm getting close, I'm going to hit the stopcock and stop it. Now I've rinsed all of the silica out of the sidewalls. It's pretty clean up here. This is what we're looking for. Now, as this progresses, you'll notice that as this column starts to get tight, then sometimes the fluid, the rate of flow starts to slow down, and that can cause problems. Like, it just takes forever with the lab. So we've come up with something called flash chromatography, which just applies a little pressure on the backside to push the fluid through. And so I've attached one of these fittings inside this tube. My air is on. Now, I don't know if you can hear that. But that's way too fast right now. I need to slow down a lot. I mean, so I'm going to slow it down. So I can just barely get any air trickle because I don't want so much pressure. I just blow this whole system apart. The nice thing is all these things are friction fitted, so if you got way too much pressure in there, either your Teflon seal is going to give out, or the little stopcock on the bottom is going to blow off. So it kind of has its own safety built in. So now what I'm going to do is I'm looking to get my solvent down. Now you can see it moving a lot faster. See the drop rate is increasing, and that's flash chromatography. All right, that's about the right depth. Now the last thing we need to do is we need to load a little bit of sand on top so we have a nice flat layer of sand. And the reason for that is when we put on sample later, we don't want to disturb this bed. We want it to be nice and flat, so we're going to put a little sand layer on there so when we put sample on, it's not going to get this column bed all disturbed. So it stays nice and flat. The littlest amount of sand. Drop that in there. Now the last thing I'm going to do here is I'm going to do a little sidewall rinse, get all the sand off the sidewalls of my system here. All the last of the silica. Push it through. Here's the silica. It's pretty consistent. There's the sand on top. And I still got fluid bed ready. And when I'm ready to actually apply sample, and by the way, my air, once I get it adjusted, I'm just going to leave it on for the lab until I'm done with this process, so that I don't accidentally tweak it and give it too much pressure. I like where I had it set. So when I'm actually ready to put sample, I'm going to make sure I get this solvent down. And again, with my flash, see the level dropping? See the drops? Now watch what happens when I apply a little pressure, how much quicker it goes. That's the flash part. I'm just going to bring that fluid down close. Now though, you have a little bit of a sand barrier. So I'll bring it right to the top of the sand and stop. Okay, now I'm ready to load sample on there. So we're going to pretend that you basically what you do as the instructions tell you how to add the amount of aspirin or whatever sample you have. I would recommend actually probably just free dropping it down onto that bed, and just you'll have a little bit of that sample just loaded right there. And so let's pretend that I had done that. We're gonna play. We'll play make-believe for a second. Let's pretend that this is actually sample. And I'm just dropping it, trying to free drop, bypass all the edges of the wall. And the sand keeps it from really screwing up the silica bed. Okay, so here's my sample layer. So before I do anything, I want to make sure I get that onto the silica. So I just press it down. Okay, now my sample's loaded, and I'm actually going to be ready to start taking sample, and see I'm still dripping. So now I'm going to ever so carefully down the side of this, just get some solvent behind it. And it's going to be a minute before sample gets there. Okay, so now I let that run a little bit. And what I'm saying when I'm saying run a little bit, what I'm trying to get you to visualize right now, the sample is coming onto the column. So now it's trapped on the column. Now I'm going to want to push it with solvent. Now I'm going to switch gears. I think I might get a new one of these columns too when I do this. Make sure this is clean. It doesn't have a bunch of silica on it. But now I'm going to actually load this thing up ever so carefully. Don't just, I'm going to load the whole both tubes up so I have plenty of solvent. Okay, now you're ready to actually start the experiment. So you got your tubes. You maybe might be worth it to have these pre-marked to what height you think you're supposed to fill them to. So let's just say that's our 5 mil mark. Whatever we're asking for in the experiment. You rack up your tubes. I have 3, but you're going to have probably 10 of them. And then here we go. So by now, we're probably sample's probably on its way to showing up. So I'm going to switch that out. Now I'm collecting sample, and I want to collect up to that height, the height of the tube. Probably easier to see if you arrange it this direction. There you go. Now you can see what you're doing. And now it's okay to apply flash, right? See, I'm going to the mark. So I'm flashing. I'm keeping an eye on the solvent, though. I can't get out of the tube. I can't go dry, so I've got to keep an eye on this solvent reservoir. There's one sample. Second sample. And I harken back to the chemistry 1 days that you don't, you know how we used to do gravity filtration and everybody sit around and twiddle their thumbs? That's why I've got these sped up techniques, because if you stuck with us this long in chemistry, you deserve the sneaky techniques to make things go faster. All right, I just didn't want my solvent reservoir to run out before the demo ended, but as you can see, I'm almost there. Now at some point you're going to switch solvent fronts. So when that happens, you're going to want that to be, that solvent all the way down to here before you switch into different solvent types. So right now I'm running, I said ethyl acetate, but you'll probably start on the hexanes end. So think back to your Chem 2, hexanes are very dispersion only force. So you start off with dispersion only, that's not binding to the analytes very tightly. And then you're going to move up polarity towards ethyl acetate, which has a little C double bond O group, a little polar group in it. And then that's going to make it more polar, and you'll just keep shifting up in polarity, and that'll help push things through at different rates. Now that you're done with this, you're going to TLC these and find out where your samples are. And then once you figure out where your samples are predominantly found, say one sample's in tubes 2 through 5, you'll combine those. Then other samples, 7 and 8, you'll combine those, and then you'll just isolate that, pull the solvent off. And that'll be the next video. All right, we're to the end of our experiment. We got all our samples. I'm just going to show you guys cleanup. So now I completely open this flask. I'm going to drain out all the solvent. Now this is all liquid waste. So this goes into the appropriate organic container down here. Then you're going to switch containers, and you're going to go to a solid waste container. Separate these bad boys. Now what you remember is there's a frit on this. That's what's holding all that silica up. Let me get that loose. Get all that business. See if we can get that frit out of there. All right, so that plastic thing's a little feisty to get off, so I'm going to just basically pop it with these pliers. Careful coming over the. Let's just see the silica. If it's dry, it'll be free flowing. But if not, I got a little wire here. Send that through. I'm going to poke from both ends a little bit. It's a little bit crusty. Got a little bitty trace silica left over. Not much. And then that can go into the liquid waste. We're going to rinse this and we're good to go. And then we're ready to clean these columns up. Teflon and the parafilm going to dry trash. Perfect. Thank you.